Hello once again, greetings. Welcome to another video. Today we are looking at statistics. Right, without any waste of time, let's look at the topics that we'll be covering, or rather the subtopics that we will be looking at. We'll be looking at the measures of central tendency. This had to do with the mean, the mode, and the median. And then we're also going to be looking at measures of dispersion, which talks about the range, the quartiles, the interquartile range, the semi-interquartile range, as well as the percentiles. And then lastly, we'll look at the 5-number summary, which will lead us to the box and whisker diagram. Right, great. Tens, I'm just going to try and cover all these with an example. Without any waste of time again, let's just quickly look at the example that I want to look at. Right, so I'll try to tackle two types of data sets. So the first one that we are given, let's look at the following. Right, quickly allow me to just cover the top part. Right, suppose we are given this question right here. Question number 3. Determine the range, the median, the lower quartile, and the upper quartile for each set of data. So we are given two sets of data A and data B, as well as number 3.2, we are given the data, which says the data below shows the number of laptops sold by 15 sales agents during the last financial year. That's their data. And then determine the median of the number of laptops sold, calculate the range of the data, calculate the interquartile range, and draw a box and whisker diagram. Right, so with either of the data, I'm just going to add two more questions which talks about percentiles as well as the mean. Right, so without any waste of time, allow me to just quickly copy the data for the first one. I'll do it on the side here. Right, so if you remember the question, okay, so the first set of data, just going to write it down. We have 10, 7, 9, 5, 8, 7, 13, 3, and 2. Right, so this is the data, and these are the questions. Grade 10s. Number 1, determine the range, determine the median, determine the lower quartile and the upper quartile for each of the set of data. Right, so the concept of range. So range by definition is simply the difference between the maximum value and the minimum value. Right, in any question that you find, number 1, you first need to arrange your data from the lowest to the highest. However, in a case of range, there's definitely no need to arrange. However, it becomes nice when one has arranged the data. So let's quickly do that, grade 10s. So we can see that our smallest number in this data set is a 2. Once I've used the 2, I normally like to cancel it out. Then I have a 3. There's my 3. Then the next number I see it's 5. So I'm actually arranging in ascending order. And then followed by the 7. There's another 7. And then after the 7, there's an 8. There's a 9. There's a 10. And then lastly, there is a 13. Right, so now after I've arranged my data, I just want to confirm I have 1, 2, 3, 4, 5, 6, 7, 8, 9 points. 1, 2, 3, 4, 5, 6, 7, 8, 9 points. Right, so from this data set, I can see this is my smallest number, this is my largest number. Therefore, the concept of range says maximum minus minimum. Therefore, I will have the maximum number in this case being 13, subtracting the minimum number, which is a 2. Then my range is simply 13 minus a 2, which is 11. Right, the first question, grade 10s, we are done. Right, second question, we need to calculate the median. So the median, this is the middlemost number. And then you can only find your median if your data is arranged. So let me just make a note. This works if your data is arranged. Right, and if you can remember, grade 10s, we've just done that right now. So we have arranged our data from the smallest to the highest. So in order for us to get our median, just use your two fingers, close the first value, the second value, close the second one this side, the next and the next, the next and the next. Right, we see that the median is actually a 7. So this second 7 right here becomes our median. And another notation for median, we refer to the median as quartile number 2. You will see when we deal with also quartiles. So our median in this case is going to be number 7. That is our median. Why do we say this is our median? If you look at your data, you have 1, 2, 3, 4. 1, 2, 3, 4. So your median cuts your data into 2 equal parts. Hence, I have 4 in the side and I have 4 on the other side. Right, the next question. I am required to find the lower quartile. So the lower quartile is actually the median of the lower part of your data. So in order for one to find the lower quartile, the first thing that they need to find is actually Q2. And our Q2, like I just said, our Q2 is our median. So we have done that. We have found our median. What one needs to do now is to focus on the lower part of your data. So if we are looking at this one as our median, we are going to close the site and then look at this data set. What is going to be our median for this data set? So again, grade 10s, you close this part, you close this part. Then when you check, you have two values. So it means your median needs to lie in between these two. And because that is the case, what one needs to do for you to find the median, we are simply going to take the sum of these two and then you divide them by 2. Therefore, our Q1 is going to be a 3 plus a 5 divided by 2, which gives us 3 plus a 5, it gives us an 8, and 8 divided by 2, it gives us a 4. Therefore, we can see that our lower quartile, which is Q1, is just a 4. Right. Again, let's go back to our data. We said on our data, our Q1 is going to be between 3 and 5. And indeed, the Q1, which is a 4, lies between 3 and 5. Right, grade 10s. Let's do the second last one, or rather the last one. So for the last one, we need to find Q3. So Q3 being the upper quartile. Right, so our upper quartile, again, we look at our arranged data. We check this one, we don't consider it, but we start looking at these numbers. Right, again, you close this one, you close this one. Again, we can see that our Q3 is between these two values, right between these two values. Therefore, we do exactly the same thing to find our Q3. We'll have the two values right here, which is a 9 plus a 10 divided by 2. Right. 9 plus a 10, you get your 19 grade 10s. And then your 19 divided by 2, you get your 9.5. Then if we check, this is our Q3. Our Q3, therefore, is 9.5, which means it's greater than 9, but less than 10, which is 9.5. Definitely, this 9.5 qualifies. Right, then that's how you find Q1, Q2, Q3, as well as the median and the range. Suppose now a question which I did say, this question wanted us to calculate the mean. So the mean, we normally use X bar. So the mean is simply the sum of the data divided by the number of the data. Right, so the sum of the data, this means what? You add and then divide by the number of the data, which means you do what? You count the data sets that you, or the data points that you are adding. Right. So as an example, I'm still going to consider this data. I'm just going to rewrite it quickly, or rather use it as I'm calculating my mean. Therefore, my mean x bar would be the sum of the data, so it means I'm going to add 2 plus 3 plus 5 plus 7 plus 7 plus 8 plus 9 plus 10 plus 13. Right, and then what do I divide it by? So remember, we said it's the sum, which means add, divide by the number, which means count. Right, so divide by the number. So for the number, we are going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So we need to divide by 9 values. And then quickly, you'll have 2 plus 3, 2 plus 3 plus 5, plus 7 plus 7, plus 8, plus 9, plus 10, plus 13. You get a 64, which is divided by a 9. And then, ladies and gentlemen, you would find that your mean is 7.11. Then that's how you would definitely calculate your mean grade 10s. Right, so let's look at the second set of data. So for the second set of data, we have, and I'm going to do this on purpose because there's something I want to show. We have 9, a 10, a 5, a 3, 11, 8, 14, 7, 11, and 8. Right, again, I did mention to say any data that you get, you just arrange first. So the smallest value that I see here would be a 3, and then followed by a 5, followed by a 7, that is followed by 2 8s, a 9, a 10, 2 11s, and lastly a 14. Again, just to check if I did not miss any value, 1 2 3 4 5 6 7 8 9 10 this time. 1 2 3 4 5 6 7 8 9. Right, so you do see that I've actually missed a value here, so help me check again. We had a 3, there's my 3. We had a 5, there's my 5. We had a 7, there's my 7. We had 2 8s, there's my 2 8s. There's my 9, and then there's my 10, my 11, and then my 14. Right, 1 2 3 4 5 6 7 8 9 10. Yes, so please let me just check again which value did I not include. I have a 3. I'm just checking with the original data, bear with me. 3, yes. I have a 5, yes. I have a 7, yes. Right, so I need to have 2 11s. Right, before this one, there's supposed to be another 11 and a 14. Right, grade 10s, this is what I actually meant. Count your data to check if you have exactly the same number of points in your arranged data set. So I'm supposed to have 10 here and 10 as well as here. Right, question number 1, the range. Right, like I said, the range comes from the maximum subtracting your minimum. In our arranged data, our maximum is 14, our minimum is 3, then giving us 11. And then the second one, calculate the median. Right, our median, again, grade 10s, you do understand that the median is actually Q2. Right, so for Q2, let's check again. You do exactly what I showed you in the previous slide. You close, you close, you close, you close, close, you close, you close, you close. And then now I can't close any further, so it means the median is also between these two now. So I'm expecting my median, which is actually Q2, to be right between 8 and 9. So if it's between 2 points, you take those 2 points, which is 8 plus 9, you add them up, you divide them by 2. Right, and then for that, we'll get our median to be 8.5. And again, median is between 8 and 9, so it must be greater than 8 but less than 9, which qualifies it as 8.5. Right, and then the next one, we're looking for our Q1. So our Q1 is the lower half of the data set, the lower half of the data. Right, so now because our Q2 is just in between these two, so we start counting for our Q1 from this point. So we close this 8, we close this one, we close this one, we close this one, and then we see that we can't close any further, but we are left with just a number. So this one now becomes our Q1. Therefore our Q1 is just a 7, and then the last one, our Q3. So it means the half of the upper half of the data. Again, because our Q2 is here, so it means we start closing from this 9 and this one, and this one, and then we are left with this one as our Q3. Therefore our Q3 becomes 11. And again, grade 10s, you can check if your data is divided accordingly. Quartiles divide your data into 4 equal parts. So these parts must be equal in 4, right? 1, 2, 1, 2, 1, 2, and 1, 2. So definitely this data is cut or divided into 4 equal parts. Then this would be our Q3. Then again, if a question were to come, calculate the mean. So the mean would be the sum of the data divided by the number of data. This time around we have 3 plus 5 plus 7 plus 8 plus 8 plus 9 plus 10 plus 11 plus another 11, then plus a 14. Then divide by the number being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide by 10 values. So we'll have 3 plus 5 plus 7 plus 8 plus 8 plus 9 plus 10 plus 11 plus 11 plus 14, which gives us 86 divided by 10, which is 8.6. Therefore that becomes our median, our mean, just like that, grade 10s. Right, so let's look at another data set. In this data set now, I'll add just one question on percentiles. Right, so this is what we are given. The data below shows the number of laptops sold by 15 sales agents during the last financial year. This is the data. Question number 1, the median, the range, the interquartile range, then the box and whisker diagram. Okay, quickly again, let me just rewrite the data. I have a 43, a 48, a 62, 52, 46, 90, 58, 37, 48, 73, 84, 68, 54, 34, and 78. Right, again, grade 10s, the best way before you start with any question, arrange your data. Right, this one, there's a lot of values, however it's still possible to arrange the data. So the lowest here, I don't see a 20, so I'll start with a 30, 31, don't see a 31, 32, no, 33, no, so it's a 34. So the lowest number here is a 34. I write it down. And then you cancel it out so that you don't repeat it. Is there any other 34? No. I see a 37. There's my 37. Right, I'm done with the 30s. I go to the 40s. My first 40 is a 43. Cancel it out. Right, I see a 46, followed by 48, 46, and two 48s, because it's this one and this one. I don't see a 49, so I can go to my 60s. So from the 60s, I can see a 60, wait, 50. So I have a 52 there, a 54 there, then a 58, then a 62, a 68, a 73, a 78, an 84, and lastly the 90. Then let's check returns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 data points. So the data is properly arranged and it's correct. Then the first question, calculate the median of the number of laptops sold. Again, median is referring to Q2, which is quarter number 2. So for quarter number 2, let's check. Close, 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 close. This can only happen if your data is arranged. You cannot find your median if your data is not arranged. And again, it needs to be arranged in ascending order. Right, after closing, I find that the only median that I have right here, right, please pardon me, this will be my Q2. Right, so my Q2 would be 54 great tens. Then B, calculate the range of the data. So our range would be max subtract minimum, which is in this case the highest number or the maximum number is 90, subtract 34. Right, you find that it is a simple 56. Then the next question, calculate the interquartile range. So the interquartile range, which can also be referred to as IQR, is simply the difference between the upper quartile, which is Q3, and the lower quartile, which is Q1. So it means from our data, we still need to find Q3 and Q1 just exactly the same way we did in the previous one. Because this is our Q2, we don't count it, we don't close it. Then we start closing this one and this one, this one with this one, this one with this one. And then 46 in this set becomes our Q1. We do the same for the upper data, close this one with this one, pair this one with this one, this one with this one. The remaining one is 73, which becomes our Q3. Once you've done the check, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3, right? Therefore, we can find our interquartile range. Our interquartile range, our Q3, we go back to Q3, it's 73, minus your Q1 is 46. And then the difference between the two, 73 minus 46, you get 27. Then that's our Q interquartile range. Right. Quick addition, calculate the semi-interquartile range. So if the question comes, calculate semi-interquartile range, this would be the IQR divided by 2. And we have found our IQR to be simply, right, let me just write this, means Q3 minus Q1 divided by 2. But we found Q3 minus Q1 to be 27 right here. That's 27 divided by 2. Then we get a nice 13.5 as IQR. Right, returns because of power. I'll just do the last one here quickly. Right, so the question says draw a box and whisker diagram. Box and whisker diagram. So for your box and whisker diagram, you need your 5-number summary. So 5-number summary. This requires the minimum, Q1, Q2, Q3, and maximum. Then from the data above, we said Q1, the minimum for this data set, the minimum is 34. Then Q1, we calculated Q1 right from this data to be 46. Right, and then Q2, our Q2 is, which is the median, is 54. This is a 54. Then our Q3 is 73. And then lastly, our maximum, this is a 90. I'm not guessing these values, grade 10s, they come from my data. Right, all I need to do is to find a suitable scale so that I can draw my number line. I'll use a scale of 10, a number line with a scale of 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Right, so from my scale, all I need to do is plot these numbers. Right, I see the minimum is 34, so I expect 34 to be, this would be the halfway, then somewhere here. Then I'll plot, this would be my whisker, right? And then my Q1 is at 46, so 46 is between 40 and 50, somewhere around here, grade 10s. Then this is where my box is going to begin. And then I have a 54 somewhere just here. Remember, you'd be doing this accurately with your ruler. And then I have a 73 just after 70, not too far. Right, so these 3 lines are the ones that are going to form my box, grade 10s. And then the last one is a 90. Then I'll have my 90 right over here. All you need to do is join this whiskers to your box. Then this would be our box and whisker diagram, grade 10, whereby this is our minimum, this is our Q1, our Q2, our Q3, and not Q4, but our maximum. That's it, grade 10s. And then a question again would come, comment on the skewedness of the data. So because we have more data on the right hand side of this than we do on this one would say this data is skewed to the left, to the right, skewed to the right. Right, I did mention that I would add one more question in terms of percentile. So your percentile divides your data into 100 equal parts. So let's say the question asks you find the data in this, what does it mean to be in the 25th percentile? Right, so Find the 25th percentile and explain what it means. Right, so your 25th percentile, number one, you need to find its position. And how does one find a position? Obviously, you'll have 25 divided by 100 multiplied by the number of data points you have. So our number of data points here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15. Right, and then we'll have 25 divided by 100 multiplied by 15, which gives us 3.75. This 3.75, we round it off to the nearest whole number, which is 4. So it means our 25th percentile lies on position number 4 of our data. Right, and then if we check, we have 1, 2, 3, and 4. So position number 4 of our data is 46. Therefore, this corresponds to 46. Then what does it mean? 25th percentile means 25% of the data. Therefore, it means 25% of the data is equal to or less than the value at that position, which is 46. And then if a question comes at 65th percentile, again, number one, you need to find the position. The position would be 65 divided by 100 multiplied by 15, which would give us 65 divided by 100 multiplied by 15, which is 9.75. Then the position is approximately 10. Then you go to your data, which is arranged, and then you go to position number 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's position number 10, 62. At position number 10, what do you find there? 62. What does this 62 mean? It means, because you're talking about 65th and 65th percentile, then this would mean that 65% of the data is equal to or less than that value at that position, and that value at that position is 62. Right, then that's about it. So please stay tuned. I will be doing almost exactly the same thing for grouped data. This was just for ungrouped data. So I'll look at the mean for group data in the next video. Right, greetings. Please again pardon me for the video. I hope, although the power is gone off, it is still visible. Right, if you have any questions, please leave them on the comment box. I will be happy to respond to them as soon as possible. Right, this was Maths Done with Molefe. See you again on another one. Cheers, goodbye.